So this is the chapter that is similarity, and in similarity we have two sections. One section is transformation. In transformation, from transformation we often get 4 marks question. So what is the transformation we'll try to understand. यहाँ पर हम समझेंगे थोड़ी देर बाद. सबसे पहले whatever we have to understand this term that is similarity. We already learned in earlier classes what is similar. So similar means any figures are said to be similar if their shape is exactly same. If the shape is exactly same, then we can say that the figures are similar. But it's not necessary. I have written here, it's not necessary that the size should be the same. Often the definition might have been changed from your actual textbook, but the meaning is the same with your textbook. So let us draw 3 figures. I am going to draw 3 figures. The very first figure is, suppose let us draw a small. So everyone can say that this is the circle with center O. Now let us draw with this figure. This is also a circle with center O. Again, let me divide this. Again, let us draw the circle with center O, and let us draw another circle of center O. And the third figure let me draw, that is, this is a circle with center O, and this is a circle with center O. So this is the figure 1, figure 2 and figure 3. Now we can see here that here the shape is circle. This is the shape of the circle, this is the shape of the circle. Here also the shape of the circle, same is the shape of the circle. Here also the shape of the circle, and this figure also is the shape of the circle. That means what? These two figures are similar. Even these two figures are similar. Even these two figures are similar. Why? Because their shape is circle. Because their shape is, the shape of this is circle, the shape of this is also circle, the shape of this is also circle. So they are similar figures. But what actually we can see from this, that the size matters. In this, the size is same. In this, size is enlarged. In this, size is reduced. So we can see that the size doesn't matter for the condition of similarity. Only the condition for the similarity matters is the same shape. Now here, now the size is same, so we can have a transformation, that is a similarity transformation. Where is the transformation? The transformation is in their size but not in shape. So we have a scale factor which is often represented in book as K. So in this we can say that the scale factor here, K equals to 1. In this, the scale factor is K is greater than 1, because if the K factor here is same size, so K equals to 1. Here K factor, the size is enlarged, so it is K is greater than 1, and here the K factor is less than 1. Often we represent the original figure or the map figure. This is the object or pre-image. We can say as pre-image. This is image, this is object, this is image, this is object, this is image. The object can also be set as pre-image. And till now we have understood what is the scale factor. When the size is same, the scale factor equals to 1. When the size is enlarged, the scale factor K is greater than 1. When the size is reduced, that is K factor is less than 1. Now actually what we have to understand from this is the problem is based in 2 different patterns. One is map, another is model, but the question or the understanding of map or model remains the same. I am going to write down some factors like linear factor, volume factor and area factor. In ICSE of 4 marks, the main question lies on actually this process, on these 3 points. Number 1, the K factor, that is the K be the scale factor. K factor यानी कि इस process में given figure जो होती है वो enlarge होती है, ये reduce होती है by scale factor. which is said to be as a K on a map or model drawn on a scale. Just now we have already seen that in earlier classes we have map 1:10 or 1:1000. So such drawn to a scale is said to be a scale factor where it is equals to K. Okay, so K equals to 1:10 or something like that. Then actual length is equals to length of the map or model by K factor. When it comes with the actual area, sometimes area is also asked to find out. Just 2 years back in ICSE question, there was a question regarding area of the model. So actual area is also equals to area of the map or the model, whatever it is given, divided by K square. If K is 1:10, then K square here it will be 1:100. Next, actual volume. For map, we know that it is a two-dimensional figure. We don't have volume in map, but for model is a three-dimensional figure. So actual volume is equals to volume of the model divided by K cube. Here K cube will be equals to 1:1000. Like this we have to do it, and just we have to do the simplification to get full 4 marks. Let us go with one example which already has appeared in ICSE. This is the question from ICSE 2018. It's of 4 marks. The question is drawn to a scale 1:50,000 a rectangular plot of land ABCD. AB equals to 6 cm, BC equals to 8 cm. You have to find out the length of the diagonal. One more question is there. That question I will write it later. First, let us solve this question. So we have a rectangular plot. Let us draw the rectangular plot in this way. Here AB is 6 cm. Let us draw A, B, C, D. So AB is here 6 cm. Then BC is 8 cm. We have to find out this diagonal AC. So with the help of Pythagoras theorem, here we can write down AC equals to root over 6 square plus 8 square centimeter, which is equals to root over 64 plus 36 100 centimeter, which is equals to 10 centimeter. Now on the map we know that AC equals to 10 centimeter, but they have asked find the length in diagonal. It should be in kilometer. Okay, we have to change it into kilometer. Now we know that 10 centimeter, here the 10 centimeter should be changed to kilometer, which is equals to 10 by centimeter, decimeter, meter, decameter, hectometer, kilometer. So we can write this much as kilometer. Now the length of the diagonal, we will find it kilometer. So the diagonal we have got, the map diagonal we got in the kilometer. Now let us change into the actual length of the diagonal. So we have, I have for you already the formula that actual length equals to length on map by scale factor. Here scale factor is K equals to 1 is to this much is the scale factor. So actual length equals to, what is the length on the map? The length on the map is 10 by 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 into 1 by K. 1 by K means this gets reversed, that is into 5, 1, 2, 3, 4, 1, 2, 3, 4 kilometer. Now let us cancel out. This gets cancelled, this 1, 2, 3, 4, 1, 2, 3, 4. Your answer is 5 kilometer. So in this way you have to make the answer. Let us go with one more question. The second question was the actual area of the plot in square kilometer. So we know that ABCD is a rectangular field. Therefore, here area equals to 6 into 8, 48 centimeters square. Let us change into kilometers square. So this becomes 48 into 1 by 10 to the power of 5 into 1 by 10 to the power of 5 kilometer square. Already we have changed into square kilometer. Now we have to find out the actual area. We know that the formula actual area equals to area of map by k square factor. Here k is 1 is to 50,000, so what we can write down is area of the map. We can write here 48 into 10 to the power of 5 into 10 to the power of 5. Here scale factor is square, k square, so it becomes the k square goes up. Here 1 by k, 1 by 50,000 means 50,000 goes upsides, so we can write square kilometer. Now let us cancel out the zeros. So 1, 2, 3, 4, it gets cancelled and remains here 10. 1, 2, 3, 4 gets cancelled and remains 10. 2 5s are 10. 2 24. 2 5s are 10. 2 12. 5 gets cancelled off. 5 gets cancelled off. So answer becomes 12 square kilometer. This video will be uploaded today, and for day 1, day 2 and day 3, more 3 important questions I shall provide in my short video. You can go through that one and get full marks in your ICSE. This is from class A to Z. Today's class was class B.